Hello everyone, welcome to Unit 4, Day 2. Today we're going to talk about solving inequalities. So yesterday, Mr. Rule put together a great video kind of going over some of the basics with inequalities, like how to read them, how to write them, based on a verbal description and what the solutions mean and everything like that, which is great. So today we're going to kind of take that knowledge forward and we're going to solve some actual inequalities today and learn how to graph the solution set to that inequality. All right. There's also a little bit of a hiccup when it comes to negatives with inequalities. We're going to talk about what a negative does to an inequality, and actually we're going to start off with that, and then we'll solve some together and make sure we look at those graphs. All right, so let's get started here. We're going to take a look at our first example. I've got an inequality. You'll notice that I have it repeated twice here. And that's because I'm going to show you one method versus another, so that way we can understand what a negative does to our inequality here. All right, so here in method 1, when we go to solve an inequality, it's much like solving an equation. Our goal is to get x by itself with a number on the other side of the inequality, just like when we solve an equation. All right, so just like with an equation, I'm going to draw a line here to separate my two sides, and then I start moving things around using opposite operations to get the x by itself. So I'm going to start with the 6x actually, right? So in this first method, I'm going to start with the 6x. I'm going to add 6x to both sides of the equation over here. Okay, and then I work left to right. So the negative 6x plus 6x, those are going to cancel out and become 0. So all that's left is 7. You can write a plus 7 there if you want, but if it's a positive 7, we usually don't write a positive sign. So you can just write it as 7. And this is greater than, and then we have 13. Oops, that should be a 6x. Then we have 13 plus 6x. And you might be like, well, that was kind of weird, Mr. Mull. Why didn't we just move something else? Well, the reason that I did that is because we had a negative 6x. I wanted it to be a positive, and it's going to become positive on this side. Now, to start getting the x by itself, what I'm going to do is I'm going to subtract 13. I'm going to move the 13 over to the left-hand side. Okay, so I'm going to subtract 13. Whatever I do on one side, I have to do on the other side. So I do 7 minus 13, which is a negative 6. Right, greater than, the 13's cancel here, and then we have 6x. Okay, and then to finish this off, this is multiplication, so I'm going to divide by 6 on both sides. So if I do negative 6 divided by 6, we get negative 1, and I'll extend my line here, greater than x. All right, so now this thing is solved. X is by itself on one side of the inequality, and a number is on the other side. All right, and we can write this one of two ways. We can write this as negative 1 greater than x, or we can write this as x is less than negative 1. Right, so we can read it left to right or right to left. Either way, this is our solution set. So x can be any number that is less than negative 1. Right, so like negative 2, negative 3, negative 4, those would all be numbers that would satisfy this inequality. All right, now we're going to go over here to the second method. I'm going to solve it in a slightly different way. All right, and I'm going to show you a little shortcut, right? Because over here we moved the 6x, then we moved the 13. We took some additional steps, and I know you're wondering why we did that. Well, let's watch what happens here. So let's say I draw my line and I start off the way that we usually start off, right? Where we subtract 7 from both sides. Right, we start with that addition and we write this out. We get the 7's canceling. We get a negative 6x all by itself, greater than, and then 13 minus 7 is 6. And then we would just divide both sides by negative 6. Right, negative 6's cancel, and we get x is greater than, well, 6 divided by negative 6 is negative 1. All right, so I write my solution down here. We say x is greater than negative 1, and we start to see an issue here. All right, so notice over here, x is less than negative 1, but over here we got x is greater than negative 1, and this should illustrate what a negative does to an inequality. All right, so when we solve an inequality, if at any point we end up dividing by a negative number, we have to flip the inequality symbol. So here we divided by negative 6, so that tells me at the end here I need to flip that inequality symbol to become x equals -1. Like, we know we did everything right over here, we did everything right over here, but we ended up with different inequalities. This is the correct inequality that we want at the end, so we have to remember to flip this inequality. Okay, so we flip it and then we end up with the same inequality. So we can use this method here and solve it like we normally do for equations. We just have to remember at the end to flip that inequality, and that's kind of the shortcut rather than doing it like this where we move the x to the other side first and then start getting the x by itself. All right. So we now know that the solution to the inequality is x is less than -1, right? So how do we graph that down here on a number line? So you have to kind of think back to yesterday's lesson where Mr. Rule showed you, like, hey, we've got this inequality. We want to make sure that we get all the values that are less than -1. So we go here to -1. This is our magic number, right? We want to be less than this. And notice that we do not have the equal to bar down here. All right, so that means we're going to use an open dot. Right? If we're not going to be equal to -1, we use an open dot just to kind of set up that boundary. And then since we want to be less than, all of the numbers that are less than -1 are going to be over here on the left-hand side of that dot. So I like to shade all of the numbers to the left of that dot and then put an arrow on the end indicating that this shading would continue on forever. So I shade because all of these numbers, right, anything to the left of -1 would work for our inequality. Right? If I took any of these numbers and plugged it back into the original inequality, it would make that inequality true. All right. So the big thing that we have to remember here is that if you multiply or divide, right, if you multiply or divide an inequality by a negative number, you must flip that inequality symbol. All right. So you can solve it like you normally do, but you need to make sure you go back through your steps, check if at any point you multiplied or divided by a negative number, and then appropriately flip the symbol. All right, so let's try a few more. All right, so I got two more here that I want to give a try. So notice here we've got x's on both sides. So let's see what happens here. I'm going to choose to put my x's on the left, and I'm going to move everything else over to the right. So when we have x's on both sides, you got to make a choice about what side you're going to put things on, right? Just like when we did the equations. Okay. So I'm going to start by moving the -5x. So the opposite of -5x is a positive 5x. So I'll add 5x to both sides. Right, working left to right, we get 10. -11 plus 5 is -6x. It's a greater than symbol right now. These cancel, and we get -8 over here. Okay. So now I'm going to take this 10. I'm going to move it over here with the -8. So it's a positive 10, so I'm going to subtract 10. 10's cancel. We have a -6x greater than -8 minus 10 is a -18. All right, so next step here, I have -6 times x, so I'm going to do the opposite. I'm going to divide by -6. Right, so we divide by -6 on both sides. The -6's cancel. X is all by itself, greater than, and if I do -18 divided by -6, we get a positive 3, but alert, 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 right? We divided by a negative number, right? So we have to flip the inequality. So flip that inequality, so our final answer here is going to be x is less than 3. Okay, so this is our final solution set. Right, so any number less than 3 is going to satisfy our inequality. So I'm going to go down here to my graph. I'm going to find 3, and since we do not have an equal to bar, I'm going to use an open dot, and I'm going to shade everything to the left, just like this. And then I throw an arrow on it. Okay, that's all there is to it. Not too hard. Just make sure you check for that flip. That's the biggest thing. Students miss it all the time. It frustrates me. All right, so here we go. So I'm going to draw a line. We'll solve this one the same way. Now I've got an x on both sides, right? So I'm at some point I'm going to have to make a choice about what side the x's are going to go on. I also see a parentheses here, and we know from equations what to do with parentheses. We're going to use the distributive property to get rid of those parentheses. And so I've got a strategy in mind. So let's go. 4 times x is 4x. And then 4 times 6 is 24. And then minus 5. And we have our inequality symbol, and we have negative 4x minus 6. We didn't do anything on the right-hand side. Okay. Another common mistake, students try and distribute to that negative 5. That's not in the parentheses, so don't distribute the 4 over here. Just leave that negative 5 alone. All right. Now on the left-hand side, I have a positive 24 and a negative 5. I can combine those. Those are like terms, so if I take those and I combine them, I'm going to get 4x plus 19 greater than negative 4x minus 6. Right? And this is where I'm going to have to make a choice about what side to put the x's on. So I always like to choose the left-hand side no matter what's going on. I always choose the left-hand side for my x's. So I'm going to move this negative 4x over here with the positive 4x. So I'm going to add 4x to both sides because that's the opposite of minus 4x. Right? Whatever I do on one side, I got to do on the other. So I'm going to work left to right here. 4x plus 4x is 8x plus 19 greater than, here the 4x's cancel, and we got a negative 6. Okay. All right, keep going here. So I'm going to move the 19 over to the right-hand side, so it's a plus 19. So the opposite would be to subtract 19. Okay, so I've got 8x, 19's cancel, greater than, and then negative 6 minus another 19, well, that's negative 25. Okay, so we're still doing good. We're on track. We've almost got x by itself. There's just got to move this 8, right? And since that's multiplication, that's linking those, I'm going to undo multiplication using division. So I'm going to divide both sides by 8. And let's see, the 8's cancel. We get x greater than, and then I would go to my calculator and get a decimal for this one. So let's see what we get. You could get a decimal, you could leave it as a fraction, whatever you prefer there. If the instructions on MyOpenMath ask for a fraction, make sure you enter the fraction. All right, so we've got negative 25 divided by 8, and then we're going to say negative 3.125. Okay, now before I say I'm done, I'm going to go back, I'm going to review my steps, and I'm looking for any steps where I might have multiplied or divided by a negative number. Right, so here I just distributed, that's okay. Here I added, that's okay. Here I subtracted, that's okay. Here I divided, okay, so hold on, I divided, but it was by a positive number, so that's okay, right? As long as it's not a negative number. So I'm going to leave the inequality symbol the way it is, and that will finish my problem. Alright guys, that's it for today's video. Hopefully you found those problems helpful. Give the practice problems a try and let me know if you have any questions in the Zoom chat. Have a great day.